so now we're going to look at a specific ANSYS example where we can apply and use our thermal elements. All right, so a brief setup for that. We have link 31, which models radiation heat transfer between 2 points in space. We have link 33. Some books use link 32. We're going to focus on link 33. Models transfer of heat between 2 nodes via conduction. And we have link 34, models transfer of heat between its 2 nodes via convection. All right, so we're going to focus on 33 and 34 in this example here. So here's an example. We've got a wall of different materials, different K values. So we got 0.08, 0.074, and 0.72 for what looks like some brick. And actually, I believe this is a representation of a chimney or of a furnace. So we have inner surface temperature of 200 degrees C, very hot inside, against some refractory materials to help insulate things. And then we have the outside fluid, outside air at 3 degrees C, and a constant convection of 40 watts per meter squared K. So we're going to break this up fairly simply. We're going to have 3 elements, 4 nodes, so 1 element for each of our materials. And let's do this. All right, so I got ANSYS up and running already, and just start it up. And so I'll go in and I'm going to create a title, change title, and we'll do heat transfer problem. All right. I'd like to go into preferences and just help myself out. I'm going to just look at the thermal items in the menus. So select that and click OK. We'll just work our way down here. We'll do element type, add, edit, delete. I'm going to add, and I'm going to do a thermal mass, and specifically a link. So that's the one we looked at. So we have the conduction link, link 33. So go ahead and hit apply on that. All right, and then we'll do convection, and we'll hit apply on that, and OK. So, I get twice there. Oh, I hit OK. You need to hit. I should hit cancel. All right, so we'll delete that one and hit close. So we got 1 conduction link and 1 convection link. So close that. Go into real constants, and we'll add, edit, delete, and add. We'll start with the conduction. Click OK, and just put an area of 1, and hit apply here. Really, that should be all we need to do. And we need to do 1 for convection. But what we found in the past is that it needs each different. If you're going to have different conduction coefficients, you should have a different real constant for each conduction coefficient. So we're going to create 4 total real constants, and then 3 different conduction coefficients and 1 material for convection. So we'll see that here, but again, we should do 4 of these. So we'll do number 2 here. Again, area 1, apply. We'll do 3 and area 1. That's good. We'll click OK on that one. And we're going to add 1 more because we need 1 for convection. So make sure you're on type 2, convection. Click OK. Change the area to 1. And click OK. Now we have our 4 real constants. 3 for conduction and 1 for convection. Click OK on that. All right, so we'll go to material properties and material models. And this is a new one for us. We go into thermal, conductivity, isotropic, and we'll just work our way across again for the different conduction coefficients for a model. So 0.08, and we're locking it in with the units. And so watts per meter K. So 0.08, and we'll click OK. And we'll come up material, do new model, make sure number 2, click OK. And we'll go isotropic again, and we got 0.08 was the first one, 0.074, click OK. Material, new model, OK for number 3, isotropic. And we got 0.72, click OK. All right. And one more time, material, new model, and we'll go OK with 4, We're going to come down here and make sure you get the convection or film coefficient. And for convection, it's 40 watts per meter squared K. Click OK. Looks good. We'll close out of that and get back to our ANSYS. And save DB. Make sure you get that. All right, so let's set up our working plane so we can get our nodes figured out here. So we're going to work plane settings, go grid and triad. 0.05 is fine. Again, just look back at the dimensions here. So yeah, 0.05 for 5 centimeters. We need 15 and 10, so that's 25 and 5 is 30 centimeters. So come down here, spacing, get that to 0.5, minimum 0. Maximum, since we're going for 30 centimeters, is 0.3. And go ahead and click OK. Okay, get back to ANSYS here. Okay, work plane. Let's display the working plane now. And get it panned over there. All right, looks good. So we're just going to be working right here. It's just a 1D analysis, so we're just going to be right on this line right here. I don't really worry about the rest of the 2D aspects of it. All right, so we're going to do modeling, create nodes on working plane. So node 1 we're going to have right there. Node 2 is 5 centimeters over. Node 3 is going to be 15 centimeters over from node 2, so right here. And node 4, we're going to go 10 centimeters over from there. And now node 5 is the node we're going to have for declare the temperature of the fluid. And then we're going to have a convection element between node 4 and node 5. So we're going to put 5 right where 4 is at. So we'll put it right on top. It looks like it disappears. We'll click OK. And it's hard to see what's going on there. So always go into list. You can go to list, check out nodes, and look at coordinates and angles. OK. So we see we're at 0 for node 1, and then 0.05 for node 2, 0.2, 0.3, and a 0.3 again at node 5. All right, so we're going to exploit that to put in our convection stuff. All right, so let's make sure our numbering's on. And turn on that as well as our elements, that we don't have any elements yet. All right, it's got the numbering on. We can turn off our working plane so we can see what's going on. Save DB. All right, so let's do our elements now. So create elements, auto-numbered through nodes. And we'll go ahead and click on nodes 1, then 2, middle click, and click OK, because we only want to do one element because we need to make sure we move on to the next one. So hopefully we got the right one, that one. All right, so it's link 33, that's a conduction element, and material 1 and real constant 1. So now that one's good. So then let's go to element 2, and we want element 2 to be material 2. So we get that conduction coefficient, and just for getting things to work properly, we'll do real constant 2. So click OK, and auto number through nodes, and go 2 to 3, and middle click, and OK. Go to element attributes, we'll go up to material 3, real constant 3, and OK, and auto number through nodes, and go from 3 to, oh, what happened there? So there's 2 nodes right there, so we get to pick. So we want to pick node 4, or we could pick node 5, but we want 4. So click OK, and OK, and then we get element 3 that shows up there. And now we want the convection element, so let's go to link 34, and we'll do material number 4 and real constant number 4. Click OK, and auto number through nodes, and we'll click on those 2. So 4, we'll do 4, and I'll come back and I'll pick 5. I got 5, click OK, and OK. So again, I want to check this, make sure I'm right, so I'll go to list, elements, and nodes, attributes, and real constants. So I got element 1 is material 1, type 1, and here's real constant, so 1, 1. And element 2 is 2, 2. Element 3 is 3, 3. Element 4 is 4, 4. Right, type 2. And we see the nodes 1, 2, 2, 3, 3, 4, and 4, 5. So that looks like what we want to have there. Again, if you need to go back and troubleshoot some stuff instead of create, you might need to move or modify. So I could have done all these elements with just the conduction element, and then come in here and modify some of the attributes of one of those. So I can just show you right here. If I click on one, all right, attribute to change, I could change material type, element type, real constant. So I'd have to do that a couple times for the ones that were off. All right, but I could come back and do that. You can also, if you need to, just delete the element outright if you need to. All right, so we got our elements nodes defined. Now we're ready for boundary conditions. All right, so save DB, and let's go down here to solution and define loads. We're going to apply thermal loads, temperature on nodes. All right, so we got node 1 is a fixed temperature, so middle click. And there's a fixed temperature there. So we'll click on temperature, it's a constant value, and right there it's 200 degrees C. And we'll click OK. All right. And we'll come back here again, thermal temperature on nodes. And now we're going to come over here because it's a fixed temperature for the air temperature. And make sure we're at node 5. Click OK. And OK here. And at node 5, we had a constant temperature of 30. So click OK. And save DB. And we're ready to solve. All right, we got boundary conditions on both sides. And come down here and solve current LS. We'll click OK. Check related, produce one warning. Should the solve command be executed? Let's go see what that warning is all about. So if we go, this is the second window opened by ANSYS. So it says the program shows an initial temperature time step. Initial time step load factor is arbitrary. This is for the user to supply suitable initial time step. So we can ignore this in this case. This is a steady state analysis, so we're not worried about any transient stuff. So we'll just go ahead and go ahead and do the solve command. Solution's done. Great. And we'll close that. Coming down here to general postproc and list results, and we'll just look here at nodal solution. Degrees of freedom, and we got the temperatures are only degree of freedom. And look at the results there. And we got our 200 fixed and our 30 fixed, and then we see the values of the temperatures in between there. All right, that looks pretty good. So, but as always, we want to verify results. So let's look and see if these values here are legit. So I'm going to go back to the presentation and do a little analysis on what we have here.